So I started a new job about 6 months ago. I moved from software to robotics, and I started doing a lot of thinking about continuous deployment. How do you do it? And how do you do it to physical devices in the real world? And if you really should do continuous deployment. MKBHD wanted to review an electric car from Fisker, but Fisker said, hold on, we actually have some updates that we want to release. So they offered to send out a field tech to his house with a USB drive and say, hold on. And he said, no, I'll just review what's out on the market already. And he ended up reviewing the worst car he'd ever reviewed. Fisker eventually released V2 over the air, but they learned, car manufacturers, like a lot of other industries, learned that hardware is hard. Sometimes you can't deploy when machines are in use. Sometimes you have low power, low connectivity. Sometimes you have low bandwidth. And we see this in cars and boats, in consumer electronics and wearables, industrial IoT with PLCs on the factory floor, industrial automation, and in smart homes, smart cities, and smart infrastructure. Another disaster, Google Nest. Google Nest deployed a huge update that caused a ton of devices to crash and lose power in the middle of winter. They didn't think about what happens if a connection drops in the middle of an update. So the lesson learned here is don't ignore network and device constraints. Make your updates as small as possible and make them resumable for when your devices lose connectivity. Another deployment disaster, Facebook. Facebook had a massive global infrastructure outage that impacted their network backbone. None of their data centers could talk to each other. This means their logging and monitoring wasn't able to work across their distributed system. And I also heard that some engineers were physically locked out of the data centers. So the lesson learned, logging and monitoring needs to work across large distributed systems. Build in redundancy with your hardware. If your hardware, communication with your hardware goes down, what's the fallback? And I heard crowbar. Crowbar was how you get into those data centers. Rivian pushed an OTA update that locked up their infotainment system. The actual build was actually tested for months on real devices. But during deployment, an engineer selected the wrong security certificate. It was a fat finger error. They eventually found a way to issue the OTA update to a part-loaded system. But even with extensive testing, it was still human error that sent the wrong build out. And they also didn't follow their playbook for incident management. So this is the head of software at Rivian posting on Reddit, the most official channel of all, about the outage, and public relations didn't even find out about it and issue an email until the next day. Oh, you guys heard about CrowdStrike. This is the closest we've come to an actual Y2K. It affected over 8 million systems, cost an estimated $10 billion in financial damages. And when you dig into the root cause, there's a lot of lessons learned, but testing basics were missed. Like testing invalid inputs, unhappy path testing, and regression testing. Lessons learned here, many, but one is tests are only as good as you write them. You can also do canary testing on a few devices before rolling out to the rest of the fleet, obviously. Blue-green deployments to roll back and restore functionality without having to wait for a fix. Or dual boot systems for firmware updates. So to recap the lessons learned, from Fisker, over-the-air updates. They give you more control and speed in deployments to physical devices. Nest, make your updates small, make your updates resumable. Facebook, logging and monitoring should work across distributed systems, have fallbacks, and have a crowbar. Rivian, it's not just the technology that needs to be addressed, but also the people that use the technology that can impact your reputation. And CrowdStrike, tests are only as good as you write them. So there's a lot of reasons why we want continuous pipelines, efficiency, reducing errors, and resilience, but also a lot of reasons why we don't want to automate all the things. You have complexity, cost, and sometimes risk. So it's a trade-off between automation and control, or said in meme fashion here. Automation is really great when the context is stable and you understand it, but you don't know what you don't know, or we heard earlier, the unknown unknowns. And this is why hardware is hard, but hardware is also like software in that change is inevitable. Thank you.